Now the second part of computing differentials. So second is y equals to cos x. So as we know that this will be equals to derivative. First I have to take the derivative of this. So derivative will be, cos derivative will be minus sine x. Okay, so this will be dy upon dx will be equals to minus sine x. Okay, so it will be dy, it will be minus sine x into d of x. This is the value of what? This is the value of d of y. Just multiplying here. Okay, so this will be dy equals to negative of sine x value is 3 into d of x is 0.1. So it would be negative 0.1 sine 3. That is dy. Okay, so this is the value of dy for my course. The next is approximating change with differentiations. So how to approximate it? Say that I have y equals to x square plus 2x, and I have to compute delta y and dy at x equals to 3 if d of x equals to 0.1. Okay, so the actual change in y if x changes from x3 to x3.1, because the exact value of 3 or the actual value of x is 3, and then there is a d of x, that is change in x. Change in x is what? 0.1. With 3 plus 0.1, so it will be changed will be 3.1. Okay, so I will write that delta y equals to function my new value, that is 3.1, minus previous value, that is the function value of 3. Okay, so it will be written as delta y equals to, now what is the function? Function is this one, x square plus 2 of x. So it will be x square. Now x value is 3.1 for this case. So it will be 3.1 square plus 2x. So 2 into value of x is 3.1. So 2 into 3.1. The negative of function value, function of 3. So function of 3 will be just putting the value of function equals to 3. So it will be 3 square plus 2 times of x, that is 3. Okay, so after the calculation, my delta y equals to 0.81. Okay, I find the first step. This is the first A part, that you have to find delta y. Okay. Now the next is I have to find d of y. For d of y, it will be equals to d of y equals to function derivative. Function derivative of what? Function derivative of 3. Okay, so basically at x equals to 3. So just putting this value, this is my actual value, or basically previous value, into dy upon dx equals to function derivative of 3. So I will write that dy equals to function derivative of 3 into d of x. Okay, so first I have to take the derivative. So it will be dy upon, general case, that is derivative of x. It will be written as derivative of x. So I have to take the derivative first. So this is y equals to x square plus 2x. So derivative will be dy function will be 2x plus 2. So my value for derivative is 2x plus 2. So I will write here. I have to erase some parts. Just 1 second. Okay. So I have to write again that my d of y will be equals to function value of 3 into d of x. So function value of derivative of 3. So my general value of derivative is 2x plus 2, 2x plus 2. Now what is the value of x? X is 3. So put here 3 plus 2 with d of x. D of x given is 0 0.1. 0 0.1. So it will be 2 times 3 is 6 plus 2 into 0 0.1. So it will be 8 multiplied by 0 0.1. So my answer will be 0 0.8 approximately. Okay, so this is the delta y and this is the d of y. Now next is calculating the amount of error. Any type of measurement is bound to create certain type of errors. In many applications, certain quantities are calculated based on measurements. Okay, for example, when I'm taking the area of a circle is calculated by measuring the radius of circle. So I have to measure manually the radius of circle, and then after I find the area of circle. So an error in the measurement of the radius leads to an error in the computed value of area. So here we examine this type of error and study how differentials can be used to estimate the errors. Okay, so suppose I have a function with a input that is measured quantity. Let's say I have to measure a function value which is measured by myself. Suppose the exact value, the actual value of the measurement is a, and the measured value I find is a plus delta x. That is, there is slight increase. The actual value is a, but the value I find by using measuring instrument is a plus delta x. So we can say that the error, this is the error delta x or d of x as an error. As a result, basically there's an error occurs in my function value. So this type of error is known as propagated error, and we can find by using this formula, that is delta y equals to function value of what I find that a plus delta x. Okay, this value is always greater than or sometimes less minus f of a function of a. So this is the measured quantity and this is the actual quantity. So since all the measurements are prone to some degree of error, so we do not have the exact value of measured quantity. So we cannot calculate the propagated error exactly. So however, give an estimate of the accuracy, estimation of some measurement, so we can use differential to approximate the propagated error, that is delta y. Specifically, if f is differentiable at a, so I will write that delta y will be equals to dy, okay, and which will be equal to taking the function value f of a with d of x, okay, and delta y also d of one, I take the measured value, so we have derivative a plus d of x into the value of d of x. Okay. Okay. So volume of a cube. Suppose that the length of a cube is measured to 5 centimeter with an accuracy of 0.1 centimeter. Use differentiations to estimate the error. Okay. First, I have to. This is the side with an accuracy of what 0.1 centimeter, I have to find estimate the error, okay, in computing the volume of cube. Then B part is compute the volume of the cube if the length is 4.9 centimeter and 5.1 centimeter to compare the estimated error with the actual potential error. So for this, in the part number 8, the measurement of the side length is accurate within this tolerance value. This is basically tolerance value. This is which is given that with an accuracy of 0.1 centimeter. This means that there's a tolerance. So tolerance must have positive or negative, whether it will be greater or less than this value. It will be positive, negative of this value, that is 0.1 centimeter. So I have to write here that my d of x, that is my change with respect to x, will be less than equals to 0.1, and it